Hello everyone. This is my implementation for the CS441 Homework 1. And I'm going to be starting off by showing you the indexer job and running it on Amazon EMR and showing you the output, which is the leucine indexes that are created using the PDFs as input. First, let me start off by saying that the cluster that I've created is now on waiting state, and this cluster had a bootstrap script. Essentially, that bootstrap script was responsible for loading all the Olama models and getting the correct Java version that is needed to run my jobs. And I can show you that in the logs here. This is the cluster ID that I just created. And in that, you can see that in the bootstrap actions, uh, let's see out. The bootstrap actions show you that the correct Java version was installed. And you can also see that it installs Olama models and warms them up by sending a request to them for embeddings and chat completion so that those models are ready and warmed up. And it also has access to the S3 buckets ready for use. Now let's start by running the first step, which is the indexer job. Before that, all these steps will be running through a jar file that I have uploaded. And the jar file is basically in S3 over here, which is the rag builder assembly.jar. This is the jar file that I will add on the step to run everything else. Now, first, let's start by uploading the input file needed for this particular operation. And the input file that I'll be using from the sample data is basically these 20 PDFs that I will be using as a sample to show you how this works. So let me upload this to S3 in the sample input folder. Yeah, that is done. And now what I will do is I will start by adding a step. So I will click on add step and it is custom jar. First, I will give it the location of the jar file that I just showed, which is over here. I will call it indexer sample job. And then the arguments. So for the indexer job, the arguments will look somewhat like this. So it takes the argument indexer, which tells it what job it's running. And then I have to paste the input path from S3 of the input path. So the place where I uploaded is over here, input and sample input. So this is the URI that I need. Replace that. And I want the output to basically be in this output slash sample output directory. So I will create this and call it rag output, for example. And before running the step, let me show you the configuration files that are used. So all the configuration is enabled to this application.conf, and some of the things are default, which is the S3 related stuff and the work directory and specific to this job, which is the LLM, what MXBI embedding model that I'm going to be using, and the chat model that I'm going to be using. And another argument that you can set in this particular job is the number of mappers. So I have 20 PDFs, so I'm going to set the number of mappers as 4. So this is going to give 5 PDFs to each mapper and end up creating 5 indexes in total. So let me start by running this particular step. As you can see that while running, it also puts its logs over here, and all these logs are also outputted to this S3 bucket. Can see that a steps folder is created, and this step basically gives me the syslog. And after opening the syslog, that you can see that it has started the job. It's currently on map 0%. And all the other logs from my actual code are also inputted here. It confirms the input output files are correct and which file system it's using, how many actual mappers it has used, and how many reducers it will use, and how many lines of input that it found inside. And yeah, we're going to wait for this particular job to finish. As you can see that this particular indexer job has been completed. Um And you can even see it in the logs that this job has been completed successfully and the mapping and reducing is done. Let's check out the actual output that is generated. So we go to sample output and we go to the rag output, and we see that all the four indices were generated, and each of these indexes have the proper segments file that can be used for ragging. Now let's move on to the next step, which is running the vocabulary statistics. This job will basically be responsible for it takes the same input as before, which is the list of PDF paths, and it's going to extract the text from each PDF as before, and from that the unique tokens, and then the mappers and reducer will be responsible for getting the count of each token and also the embedding of each token. So the count and the unique token ID and the embedding of each token is generated using this job. The reducer basically aggregates the count, averages out the embeddings, and also assigns unique token IDs to each token. So since it's the same input, let's start adding the step. So I'll add the step. It's the same jar file that I have used before. So I'm gonna copy that right here. I'm gonna call it vocab job sample job. And for the arguments in this case, so for my code, stats word tells it that it has to run this vocab job. And for the input, it's the same input that we've been using for the PDFs. So let me go there, data, input, sample input, and this. I'm gonna replace that with this. And for the output, it's the same. To copy this. And let's call it vocab output. And similarly, it's 20 PDFs. So I'm going to give four mappers again, which is five PDFs per mapper. So it's going to run five PDFs in parallel each in each mapper. So yeah, everything looks correct. Let's start the step. Okay, the step has been started. So as you can see that the logs for this job is created as well, and these logs are visible over here. So this is the second step that I started right now. And you can see that once I open it, 80% mapping right now, and all the logs from my code are also put here. The input output file, the number of mappers, it knows what the input file and output file are, and the number of reducers. Just wait for this job to finish. This job is now completed, and looking from the logs directly from the EC2 instance, you can see that this job mapper reducer job was completed successfully. Yeah, job completed successfully. And now let's actually check the output that it's created. So it should be in this output file. Yeah, vocab output. And you can see these reducer outputs were basically each of the tokens, since there were four reducers, that it was divided into four, and then I combine it into a single CSV file. A reducer output basically looks like this. So you can see the embeddings that are created and the nut counts. It will become more clearer in the CSV file. So let's open this particular CSV file. Yeah, you can see that these are the words, capability, carried, and all these words. These are the unique ID that's assigned to them. This is the count, and this is the embedding generated by the MXPI Llama model for these tokens. In these complete CSV file is generated. So now let's move on to the neighbor's job. So this pertains to the task in the assignment where we have to calculate similar words for each word in the vocabulary. For example, I'm doing it by calculating the top k neighbors based on cosine similarity for each word in the vocabulary. Now, the total number of words and their embeddings that I calculated in the previous vocabulary statistics job, for example, in this vocab embedding sample.csv, these are a lot of embeddings and a lot of word, around 10,000 words for this particular sample. So the way the map reducer will work is it will break down these words. For example, 10 segments will break them down into 1,000 words each, and each mapper will get one particular segment. You can break it down into more number of segments and so on. And uh, I will not randomly partition these words. To partition them smartly, first I run a k-means clustering algorithm. So this k-means algorithm basically first groups somewhat similar words together. So it will run few iterations of the k-means algorithm, and it will start by grouping the embeddings of the words around some centroids. So for example, I can group them into 10 centroids. So it will create 10 shards of the 10,000 words, and each of those shards will have somewhat similar words so that when they're operated in parallel, uh, when they're operated in parallel, it is a high chance that the accuracy of the similar words will be higher since the similar words land in the same particular shard. That's why I run an initial k-means clustering algorithm. So this vocab embeddings file is basically converted into a sharded file, which basically looks like this. Let me show you. So each shard will be responsible for some of the words. For example, shard 0 be responsible for similar words. Shard 2, for example, will be responsible for similar words all the way till shard 9. So I have given 10 centroids for this. And the number of centroids and all such things are configured in the application.conf directory. For example, this neighbors jobs, the number of centroids is 10, and the top k similar words for each word is set as 3. So these are configured over here. And now let's start. And also, essentially, the number of reducers then basically will be equal to the number of centroids. So if I have 10 centroids, there will be 10 reducers. Since each reducer will only be responsible for performing the cosine similarity job for its particular shard of words. So the mapper's job over here is to basically just output a key value, which is the centroid or the shard ID, and then the particular word and its embedding. And this so that this ensures that each reducer does not get the complete 10,000 words, but only a partition of the 10,000 words, and so that it does not take that much time and runs everything in parallel. So let's start by adding the step. So let's add the step. Again, it's going to be the same script as before. Gonna call it neighbors sample job. And yes, for the arguments. So the neighbors keyword tells my code to run this particular job. Let's get the input right. So the sharded file that I just showed over here, uh, I've already uploaded to S3. Copy this. And then let us fix the output as well. Let's call it neighbors output. And the number of mappers here is basically just to divide the files, the lines that go to each mapper. So I'm choosing that as 12 over here. And the number of reducer, as I initially said, is set according to the number of centroids that is in the configuration. So these are the number of shards that I want each reducer to work on. So let's begin by starting that step. You can see that this job is currently running, and looking at the logs directly from the EC2 instance, you can see that the mappers is just an identity mapper, just mapping the centroid ID to the particular word, and the reducers are the one that's doing the n squared loop for the similarity. So we're at 20% reduce and mapping is already 100% done. Each reducer should be, so if there's 10,000 words, then 1,000 words per reducer. Each reducer should be working on a 1,000 squared loop. You can see other logs. You can see it uses 10 reducers as mentioned by 10 centroids. Number of mappers is 12, got the input and output file and all the logs, and found 9,468 tokens to be exact. And these are from the logs. And let's wait for this job to finish. So you can see that this job was successfully completed. And let's actually check the output if it created that correctly. So let's go to the output. Yeah, neighbors output. So each of these reducers has processed a part of the 10,000 words, for example, showing you any reducer output. Yeah, you can see that the word is then mapped to its particular neighbors that it's supposed to have. And this was only 1,000 words per reducer. And that's why the whole job, even for 10,000 words, was pretty quick. And I have merged this into the CSV file that is to be uploaded. So Here's the merged output. Let's open this. Yeah, so you can see these are all the words, and let's look at some legible examples. Yeah, for example, so you see for this word, and these are the top similar words to this particular word. There's going to be some drop in recall and accuracy because let's say the actual similar word would not have landed into this particular shard because the k-means clustering only ran for a few iterations, but that's the trade-off that we have with parallelism here. For example, independent is mapped to individual, single, native, Germany to German, Munich, Berlin, and so on. So all these are the nearest neighbors for each of the words. So now moving on to the similarity job. So this is the job basically defined in the assignment where I have pairs of words and I need to evaluate whether the similarities calculated by my llama models is a good enough, which shows that these words are synonyms of each other. So this is the input that going to be uses. I have synonym words that I expect to have a high degree or somewhat high degree of similarity using my model. So the way the mapper reducer works on this is that I'm going to be dividing this into parts for each mapper to run parallelly, and each of the mapper opens a cache file of the embeddings file that it has and looks up the embeddings of the words in it and calculates the similarity using that. So each of the mapper uses a cached embeddings file. I'll show you that in a bit. So let me start by first uploading this file into the correct folder. So we're in input. So I'm going to upload this file, word sim, and upload. And you can see, and I have a vocab embeddings CSV file ready. How the mapper reducer works is it's going to look for embeddings file in the same input directory as the input file that it's looking for. So this embeddings file will have basically each word and its embedding, which I already created using the vocabulary job as I showed before. So let's start by adding the step. So let me add a step. I'm going to call it similarity sample job. And yeah, as before, the same script, the same jar script that I've been using. And as for the arguments for this, yeah, so the similarity word basically tells my code to run the similarity job. Let's fix the input path quickly. So this is the input file. And as I already said, it's going to look for the same vocab embeddings file in the same directory as the input file. And yeah, for the output, call it word sim output. And I have I have 20 pairs of words. So let's go for with four mappers. So five pairs for each mapper in parallel, and each mapper will have its own cache of uh, embeddings to look in. So let's start by adding this step. So as you can see that this job is now completed, and the logs show that as well. The job was completed successfully, and it also created a combined CSV file at the particular output. So let's check the output out here. Yeah, so there's the word sim output, and the reducer and the CSV file is the same. I just converted it into a CSV for the assignment's sake, and let's actually take a look at the CSV. Yeah, so as you can see that it clearly shows that, these type of words, architecture, construction, big, large, they have high similarity values. Some of the dicey synonyms like flexible, adaptive, they have 65% similarity, which is somewhat good. And the obvious ones like slow and sluggish have 86%, small and tiny, system infrastructure have somewhat good similarities. And so this job works. Now moving on to the last of the EMR jobs, which is the analogies job. So in this assignment, we had to, the first three words here basically works like the vector embedding A minus embedding B plus embedding C should somewhat equal to embedding D. And so I have created 10 such triplets or quadruplets of words over here, which I expect the answer to be. For example, summer minus hot plus cold is winter, and engineer minus engineering plus medicine is doctor, parents minus France plus Germany is Berlin. So let's start this step. And similar to the similarity job, it's going to have the vocab embeddings file in cache for all the mappers. So let's start by uploading this file. Word analogy. Is it the correct one? Second. Yeah. Gee, load it. Okay, and now let's start adding the step. Do the same thing. Here's the script. Call it analogy sample job. And yeah, as for the arguments, we paste that. Yeah, so the analogy keyword tells my code to run this particular job. Let's correct the input here. And the output. Let's call it word analogy output. And since it's just, yeah, let's say it's 10 quadruplets, 10 lines of words, I'm going to choose three mappers, around three lines per mapper. So not all the vocab embeddings loading is running in sequential, it's actually running in three mappers parallelly. Let's check it once and we're ready to run this step. So as you can see that this job is already running, and looking at the logs directly from EC2, we can see that uh, yeah, mapping was started. And just to show the logs, here's the logs from my word analogy code. And again, it found the embeddings file from the S3 path, the same input path. And yeah, this job is actually already completed, as we can see, saw from the logs already. And let's actually check the output that it created. This word energy output, and looking at the CSV results. Yeah. You can see this is the results that it got. For example, book minus read plus watch equals to video with 69% similarity. And summer minus hot plus cold equals to winter, which is the answer that we wanted. Running minus run plus walk is walking. And Paris minus France plus Germany equals to Berlin. So this job also works.